No, that is not. That is not. Number 13. All right, your homework should be out. We're going. We're going.
All right, I have a question.
All right, guys, lock in. Okay, switching to 15. 15, we have sine to the negative 5 minus cosine cubed. Can I do these two separately? Yes, why? Subtraction if I'm adding or subtracting. All right, so I got a trig function. Order of the trig functions is what? The exponent, the trig, then the what's in the parentheses. That's exactly right. All right, so do the exponent first. What do I have? Then what? Now the trig function, right? That was the exponent. Now the trig function, which is negative cosine. And be careful because this is not subtraction. Oh, not negative. Sorry. I'm looking at that negative 5 in front. And then what? Just 1 because the derivative of x is just... No, you don't do the exponent then, whenever you do it. All right, minus power, trig, and then the argument, but 1, right? And you can clean it up a little bit. Why? So that's what you're supposed to do. That is what you're supposed to do. Well, I would definitely at least change, since you got a negative and a negative there, I would at least change that to a plus. I don't know that there's a whole lot, I mean, unless we get into factoring out, I would probably leave it there. What? Was it?
Wait, go back.
Oh, sorry. $19. Which one? But we did that one together. All right. 19. 19 comes before 27. Then we'll do 27. All right. If I am working this one, I would do the same. Did I tell you that yesterday? You thought about it on your own. Good job. That's good job. Hey. I thought I remembered telling y'all to do that, but I was. All right. All right, he's going to tell us after the lesson. All right, so if I find the derivative, if I ever get stumped, I always want to see if I can rewrite it, right? So here, I could do the quotient rule here, but if I can ever avoid quotient, I always try to avoid quotient. What? You can't do that. Oh. Yes, I would do that too. I would do 2x plus 1. That's what I would do if I were doing this one. Yes. I said make it a negative exponent. That's not the derivative, though. I just rewrote it so the derivative would be easier. If you use quotient, you're not wrong. It's still okay. I can do it that way, too. All right, let's keep chugging. That's right. dy dx is, so I'm going to do power rule first. Negative 3 over 2. All this stays the same. Subtract 1 from the exponent. Now chain it. Now you're to the bubble gum. 2. There's your lows when I say that. Y'all are lying right now. I Listen. Yes, yes, what?
I'll never work the door to like get the date.
Yes, I will.
Because I hate going all the way to Canada and figuring out which one it is and then finding it. I'd rather have it all.
So you know if you go to the modules, there's a heading with the date on it under the module, and then the homework is like, okay. Okay. I can do that. I can do that. I can do
Right
that.
now, are you gonna put the date for the date?
Which would you prefer?
I would rather do like 3.1 chain rule. Whoa, don't listen to.
I think yeah.
What if I put chain rule do?
Yeah.
Okay. Done.
Thank you.
All right. Listen, what? I'm gonna forget. Is that what you said?
Don't forget.
I'll try to remember. Okay. You should remind me every day. Okay, I could, but I want to make sure you understand how this could be manipulated, just in case this is a multiple choice question, and that's not the way the answer looked, right? So it could be right. It could be that it's back under. It could look something like this. I don't know how they formatted the answer on here. They left it like we did here. What it looked like starting out. That's what I thought, and that's since it started out with the radical. I was thinking they would probably put it, but they actually left it with the negative exponent. Isn't that weird? Boo! All right. What else did you say? That was 19. 25 and 27, or just 27?
25, 27, and 30.
Oh my gosh. Don't worry, by the time I'm finished, I'm sure we will be through almost all of them. Theta's just x. So, all right. Look at the way this is different. Get used to seeing the derivative taking theta in that notation, right? I'm still just being asked to find the derivative, but with respect to theta. Theta is my variable here that I'm using. Wait till we do implicit differentiation next. You will love it then. Okay. So exponent, that's right. So it's the derivative of the trig function. So the derivative of tangent, the one that Wyatt loves, he always remembers that. Secant squared, keep the inside the same. No. -1. Thank you. Thank you, Davis. Why is it -1? It's negative theta, so the derivative of negative theta would be -1. So negative. This was more to get you used to that notation, drd theta. Did he have it or not? Ooh. So the derivative of the inside here, the derivative of negative theta would be -1. Twenty. What'd y'all say? 29, 27? What'd you say? 3?
Not actually.
Logan. They forgot to ask about this one, but this one I mentioned to you yesterday. All right, listen. That square root is only going to the 3. So if you got confused, it was probably because you thought the radical applied to both and not just the 3. So derivative of y here, what's the derivative of cosine? Negative sine. This is 3.
My 3 was way different.
You did the quick review, Wyatt. Is your 3 g of h of x? Oh. That's 2. Chain it. What's the derivative of the argument? Root 3. Root 3. Not the x, but this, because, yeah. Negative square root of 3. I'm going to move that to the front because it's square root of 3x. What's the derivative of 3x? Right, 3. So what's the square root of 3x? All right. Did you say 27 or 29? 27. Why are y'all going back and forth? We need 9 or we don't need 9? Okay, 9. We just did 3. All right. Power trig argument. Power trig argument. There's no power, so move on to the trig. Negative sign. Everything inside stays the same. What? Times negative 3. That's exactly right. The negatives make a positive. Thank you, Davis. 3 sine pi over 2 minus 3t. Well, pi over 2 is a constant, right? There's no variable to it. The variable of pi is a constant. This is a constant. It represents a specific constant.
Okay, name as far as you can is pi.
Yeah.
Hey, I can go farther.
Okay. Reader, you're looking. All right, guys.
No, they don't. They do it after lunch. Unless they change the short time so they don't.
It's either first or second. It's not third, I don't think. I checked that. Unless they've changed it. They'll get scared away. They won't ever come back. What else? What else? That was 9. Anything?
8.
What'd y'all say? 27? All right. Look. No, don't make her say that next. All right, look.
Wait, why?
This is going to have product rule and chain rule in it. That's probably why you're struggling. All right. Do you see why it's a product rule? All right. So work your way outside in as you do this, okay? And I would definitely make this an exponent. Yes? All right, so let's do the exponent first. What do you get? 1/2. Everything inside stays the same, and then y it says negative 1/2. Now I have to do product rule. I'm going to put this in brackets so I remember that what's in front multiplies to everything in these brackets because I'm fixing to get into some work. Derivative of the first one, because it's multiplied there with the, yeah, sine theta, plus the first times derivative of the second cosine theta. I want to hear the story, but not right now, but I do. If I go back to that same thought process of rewriting here, I could change this sine theta plus theta cosine theta would be all on top of the fraction, and I think it's good to recognize because otherwise you might not realize that this is everything in those parentheses bounce and everything. But now I'm going to put the 2, yes, square root theta. And that's probably how I would leave it. I don't know how they left it. Okay, yeah. Does that make sense? No, where does it?
I don't understand the why it's a fraction.
I took the negative exponent and I moved it down to the bottom, and because it's a half, it's a radical. The two is coming from this 1/2.